Let's do section 11.3, page 564, exercise 3, which reads, plot each point with the given rectangular coordinates and find two sets of corresponding polar coordinates. For part A, our rectangular coordinates are -1, 1, so that's an x-coordinate and a y-coordinate. And when we plot that, we can see that that's going to correspond to a point in quadrant 2. So it's going to be up here, and that's going to be -1, 1. And we want to convert this into polar coordinates. And remember, for polar coordinates, we want to know r, the length of the ray, and theta, the angle that the ray makes with the positive x-axis. So we have here a y-coordinate and an x-coordinate that correspond to the x and y coordinates of point P. And so because x and y are the legs of a right triangle and r is the hypotenuse, we can use the Pythagorean theorem to find r. So r is going to be equal to the square root of -1 squared plus 1 squared, which is going to give us radical 2. And we notice that the x and y components have equal magnitudes, which means that this reference angle over here has to be 45 degrees, or pi over 4, and that's going to tell us that theta is going to be 3 pi over 4. So one of our new polar coordinates can be radical 2, 3 pi over 4. And then, of course, if we continue around this circle again, we will come back to 3 pi over 4 after another 2 pi. So we can add 2 pi to 3 pi over 4, and we get 11 pi over 4. So those are two possible polar coordinates. Now for part B, we have an x component of 1 and a y component of negative radical 3. So when we draw this, we're going to get a point in the fourth quadrant. So we're going to go over 1 and down radical 3. So we're going to get something over here. And again, P is going to be 1, negative radical 3. And so we know that our x-coordinate is going to be 1 and our y-coordinate is going to be negative radical 3. And when we are dealing with polar coordinates, we want to know the radius r and the angle theta that the ray makes with the positive x-axis. So again, we can use the Pythagorean theorem to find r, and we're going to get 1 squared plus negative radical 3 squared, which is going to give us 2. And we can say that theta is going to be equal to the inverse tangent of radical 3 over 1, which if you plug into your calculator will probably give you something like 1.047, which you can check because that is pi over 3. So one possible polar coordinate is going to be 2, negative pi over 3 because we're measuring in this direction. And of course, we could also measure the angle by going around that way. So a second option would be 2, 5 pi over 3. And those again would be two possible corresponding polar coordinates. All right, for part C, our x and y coordinates are 0 and 3. So when we plot this, we can see that it's going to be on the positive y-axis. And so this is going to be r, and by inspection we can see that r is going to be equal to 3, and that theta, which we measure this way, is going to be pi over 2. And so one choice for polar coordinates will be 3 comma pi over 2, but another option would be -3 comma 3 pi over 2. And so remember, when we have a negative sign here, we use the angle, so we would go all the way around here to 3 pi over 2, but then the negative sign tells us that instead of measuring this way, we measure in the opposite direction. So those again are two possible polar coordinates. Our final example is -1 comma 0, and this is going to be on the negative x-axis. So we're going to go over here, and this is going to be -1 comma 0. And again, by inspection, we can see that r is going to be 1 and theta is going to be pi. So one possible polar coordinate would be 1 comma pi. And we could also use 1 comma -pi. And of course, there are many different ways that you could come up with polar coordinates to express these rectangular coordinates.